In today's video, we're going to be talking about projectile motion once again. And the reason this video is going to be a little bit different than the previous one is we're going to be talking about some of the formulas and the math that goes into solving projectile motion problems. So a lot of them are going to be examples and things that I'm going to be going through, and I highly recommend writing these formulas down in a safe place that you can refer to frequently, because if a problem that you get on the homework is similar to one of these problems, well then it's really easy to just whip out that formula and use it. So anyway, here we go. Once again, looking at some projectile motion. And remember, projectile motion is basically an object that is solely under the influence of gravity. That is the only force acting upon it. And so this is kind of a cool picture. This cannonball is being shot out of a cannon, and you'll notice it's leaving the cannon with a speed of 20 meters per second. After 1 second, the only force acting on the cannonball is gravity, and you'll notice it has a velocity of negative 9.8 meters per second going down. But notice the x velocity is still 20 meters per second. And then another second later, still x velocity is 20 meters per second, but the y velocity is now negative 19.6 meters per second. Basically, we've doubled this velocity, and it continues to add 9.8 meters per second every second, because that is the acceleration due to gravity. The acceleration due to gravity on Earth is 9.8 meters per second squared. So that's basically what happens is for every second an object falls, it speeds up by 9.8 meters per second. And you'll notice again, the horizontal velocity never changes throughout the entire flight. How come? Well, this velocity, the horizontal velocity, or the x component, never changes because there is no force acting upon the x component. Without a force, there's no acceleration. Without an acceleration, there's no change in the velocity. Okay, which is, I know, kind of hard to wrap your mind around, but we need to be able to do that. Just if you're thinking, hey, what about air resistance, Benny? That's a great question. Air resistance we are ignoring. Okay, so we pretend it doesn't exist because that just adds a whole other ball of wax to all these problems. So we very rarely will deal with air resistance in this course. Okay, so there you have it. Now let's take a look at a cannonball that's fired at an angle. This cannonball is being fired at some angle, and basically, luckily for us, this picture broke it into components already, into an x component and into a y component. So it's heading up in the y direction at a speed of 19.6 meters per second, and the x direction at 73.1 meters per second. If you were a betting man and didn't look at this picture real long, what do you think the velocity will be in the x direction for every single moment that this cannonball is being diagrammed? If you're saying 73.1 meters per second, you are right, because the horizontal component of velocity is never going to change in a free fall problem. Okay, there's no force acting in the horizontal component. So you'll notice all of these, v sub x equals 73.1 meters per second. But anywho, this cannonball goes up, and as it goes up, it's slowing down. Notice it starts off at 19.6, now it's down to 9.8. Here, it actually has no y velocity. It's actually 0 because it's actually changing direction. It's going to start to head down now. And now it starts to head down, so you have negative 9.8, negative 19.6, negative 29.4, and so forth. Okay, so it starts to speed up as it heads down back to the Earth. And you'll notice this parabolic path that it kind of takes. Okay, it's this nice arcing path, and I'm not a good artist, but there you have it, this parabolic path at which this free-falling object travels. Okay, so just kind of a recap from the previous lesson, taking a look at some of the things that we talked about. Let's get into kind of the new stuff here. Again, maybe this isn't that new. Vector resolution is taking a single vector at an angle and separating it into its perpendicular parts. If you're still struggling to do this, we really need to get you caught up, because the course just progressively gets more and more challenging, and I'm going to start making the assumption that you know how to break vectors into components real soon. So if you're struggling with this, make sure you either check out some previous video series, talk to a friend, see me, whatever. All right, anywho, I want to take a look at this practice problem. It says a projectile launched with initial velocity of 50 meters per second at an angle of 60 degrees above the horizontal. And we want to break this into components. Okay, so let me first get a white pen color here and draw some axes. Here is the y-axis. Here is the x, and if you want to label it It's cool with me, okay? Now, let's draw the actual object being fired in green, shall we? It says that it is launched with an initial velocity of 50 meters per second, 60 degrees above the horizontal. So I'm just ballparking it. I do not have a protractor here, but I'm going to pretend this is about 60 degrees. Okay, right here, this angle is about 60 degrees. All right? And it has a v sub I of 50 meters per second. Okay, so that's pretty fast. All right. The question is, what is v sub I x? I should put the x in there. That would help. V sub I x, and what is v sub I y? Okay, so basically if I were to break this into two components, a horizontal component, aka the x component, and a vertical component, aka the y component, what would the initial velocities be in each of those directions? Okay, so let's go back through the steps on breaking this into the various components. Let's see here, what color would be cool to use? Let's do red. So this guy right here is going to be v sub I x, and then this guy, and this is about as straight as I get, this will be v sub I y, okay? And then the hypotenuse is 50. I'm just kind of transferring that over there, okay? So I'm going to have to use some of my trig functions to figure this bad boy out. And let's see here, let's do magenta. That sounds exciting. So first I'm going to do the y component, okay? And to do the y, and you can do whatever order you want. There's no method to my madness, it's just kind of whatever I feel like. So I'm going to do sine. Sine equals the opposite over hypotenuse. So sine 60 equals opposite, which I'm just going to call this y, over hypotenuse, which is 50. And that looks almost like a 4, so let me change that. So basically, if you just cross multiply, sine of 60 times 50 would give you a v sub I in the y direction of 43 meters per second. Okay, that's one of them. That's one of the components. Let's do the x one. That would be cosine 60, which is equal to the adjacent, which I don't know what that is. I'm going to call it x, over the hypotenuse, which is 50. So basically cross multiply, cosine 60 times 50 would equal a v sub I x of 25 meters per second. Okay, we broke it into components. How exciting. Okay, so this is kind of the entryway into talking about projectile motion, because once you know the x component and the y component, you can start using formulas to figure things out, which becomes very exciting. So let's talk about the first formula that we're going to talk about here, which is called time of flight. All right, this formula here is the time of flight to get to the peak of the projectile, time of flight to get to peak. So how do you do that? Well, basically it says if a projectile is moving upwards with a velocity of 39.2 meters per second at 0 seconds, how long will its flight be? Okay, so they've already broken this into components. So you can take assume that this is v sub I y, that this is the y piece of it. That's 39.2 meters per second. And we don't care about the x. You notice the formula doesn't ask for the x component, because the x component has nothing to do with gravity. Okay, those two do not like mix with each other. So v sub I y equals 39.2 meters per second. How long will the flight be? Well, g in this formula is 9.8 meters per second squared. Okay, so basically I'm going to just plug numbers in. 39.2 divided by 9.8. If you do that, it equals about 4 seconds. Okay, so what does that mean actually? Well, let's get a picture here. Let's do a different pen color too. Let's do yellow. So let's say you I don't know, you're here and you throw a ball, and the ball's path looks something like that. And this should be about as like parabolic and even as possible. I just am not a good artist. This formula, T up, determines the time to get to the halfway point. This point right here, the maximum height, the peak. That's how long it takes for it to get there. So this would take 4 seconds to get to here. Okay. The question is, how long will its flight be? So 4 seconds isn't really the answer. That's half the flight. What would the whole flight be? Well, we need to multiply this by 2. And if we do that, 4 times 2, it would take 8 seconds for the flight of this object. Okay. Let's take a look at horizontal displacement. Horizontal displacement, which, man, that sure sounds like the x component of vectors. All right. Horizontal displacement of a projectile is dependent upon the horizontal component of the initial velocity. Okay. And here's the formula for it. X, which a lot of times is referred to as like the displacement, x, and the displacement, I should say, in the x direction. So I apologize. Displacement in the x direction equals v initial x times time. Okay, so here's just a practice problem for you. A projectile has a time of flight of 8 seconds and a horizontal velocity of 20 meters per second. So they've broken this into components already. Basically, they're saying v sub I x equals 20 meters per second. And if you're saying, how do you know that? When they say horizontal velocity, that's kind of a big giveaway. They're talking about the velocity in the x direction. So v sub I x is 20 meters per second. The time of this flight is 8 seconds. Okay? What is the displacement? Well, I'm just going to use this formula, and I'm just going to drop it down here. Okay, so x equals v sub I, which is 20 meters per second, times the time, which is 8 seconds. And if you do that, you should get 160 meters would be the displacement, the horizontal displacement. So this thing would travel 160 meters, okay, if it was in the air for that long. All right, one more formula to show you guys. It says determining peak height. Okay, so this really is another way of saying this is the maximum displacement in the y direction. Okay, because the peak height is going to happen in the y direction. Maximum displacement in the y direction. Okay, so it says a non-horizontally launched projectile. So basically a projectile that kind of like does one of these numbers. Okay, with an initial velocity of initial vertical. That's a key word. Vertical velocity of 39.2 meters per second will reach a peak in 4 seconds, or will reach the peak in 4 seconds. So when they say vertical velocity, basically they're saying v sub I y. Okay, the initial vertical velocity in the y direction is 39.2 meters per second. And it'll reach the peak in 4 seconds. Okay, so my t is 4 seconds. What is my displacement, okay, or my y? Well, I'm just basically going to use this formula, right? Y equals v sub I y, which is 39.2 meters per second, times the time, which is 4 seconds. And by the way, these big old dots, that's supposed to be multiply. I apologize, those dots are way bigger than I really want them to be, but that's to be or supposed to say multiply. So v sub I y times the time, which is 4, plus 0.5, or another way of writing that is 1/2, times the acceleration due to gravity, and make sure you put the negative sign in this one. This one is kind of important. In the previous one, where we were dealing with time, like 2 slides ago, time will never be negative, so you don't have to really worry about that too much, but in this question, it needs to be negative. Times time squared, and sorry, I am running out of space, but times time squared, so 4 squared. Okay, so that's supposed to be down here. Okay. All right, so if you throw that all in your calculator, 39.2 times 4 plus 1/2 times negative 9.8 times 4 squared, you would get a y, or a vertical displacement, of 78.4 meters. That's how high this thing would go from the starting point to here. That would be a total height of 78.4 meters. That takes care of this video. I will see you guys next time.